Okay, good afternoon. So, any questions? I'm not going to discuss all of these, so maybe we can begin. Yeah, 21. Okay, Hmm, starting from question 21. So, I think let me copy it from here to a new page. So, we have to evaluate this line integral where C is a line segment from 0 to 1, followed by the line segment from 1 to 1, and this is the vector field. So, to begin with, we need to determine what is the parameterization of the curve. For that one, since these are line segments, so it's very simple to write a parameterization. It starts from 0 to 1. So, let us say this is origin and this is, no, this is not 1. X is 0, y is 1, so it is this point 0, 1. So, we are moving in this direction, and then from 1 to 1. So, for example, if this is 2, then this is the next point. So, this is the whole curve C. We have to evaluate line integral over this one. So, the idea is to divide this curve into two smaller curves, C1 and C2, and solve the problem for C1 and C2 separately, and then add these two. So, for C1, we need to determine what is the parameterization, like what is x of t and what is y of t and what is the range of t. You can see the value of x remains 0, that is why x is 0, and the value of y goes from 0 to 1. It is a straight line, so y of t is equal to t when t is between 0 and 1. Okay, so y goes from 0 to 1. Is it okay? Okay, so this is for C1, and then there is usual process. There are certain steps to be followed. R of t is equal to x of t I hat plus y of t j hat. Since x of t is 0, so this one is only t j hat. And then we need to substitute this into the vector field f of r of t. The vector field is this one. This simply means that I have x plus 2y I hat plus y minus x j hat, because there are different ways to write the vector. So, this is just maybe the components are written in this parenthesis. So, some people prefer this notation like x component I hat plus y component j hat. Some people prefer this notation x component y component, and in some books you also find these what do we call these, okay, whatever you call this, we call this inner product as well, and there's x and y both components. So there are different notations. We mostly follow this I and j, but there's no difference. Okay, in this one I need to substitute x is equal to 0 and y is equal to t, because that's the position vector. That's the position vector for the, like, that is a curve that is given to us. So x is 0, y is t. This becomes 2t I hat, the first one, when x is equal to 0 and y is equal to t, and when x is equal to 0, y is equal to t, here this becomes t j hat. The next thing, if you remember these all these steps, was to compute r prime of t. It means we differentiate this one. So if you differentiate t, you get 1, so it's only j hat. And after that, I think the fourth step was you take the dot product of f of rt with r prime of t. So the dot product is you take the dot product of these two vectors, 2t I hat plus t j hat dotted with j hat, and their dot product is, I am simply multiplying j components because there is no I component in the second one. So you can see t is here and here I have 1, so t times 1 is equal to 1. So this is the dot product. Sorry, it's t. Yeah, thank you. And then finally, the line integral over C1 is f of r of t dotted with r prime of t dt. The limit of t is from 0 to 1. So this whole thing is simply equal to t. You integrate this one, you get t square divided by 2, apply upper limit minus lower limit, you get 1/2. Similarly, you do the same thing for this C2. The only thing you should begin with, what is x of t and what is y of t, and what should be the limit of t. For example, you are moving in this y direction, sorry, in this x direction, and you are not moving like you are not going up or down, so the y is 0, and x, since it is a straight line, I am going to call it x is equal to t when t goes from 0 to 2, or I can say x is 2t when t goes from 0 to 1. For both of these you will get the same answer. Okay, so these are like different parameterizations that you can use. So x is equal to 2t when t is between 0 and 1. You do this whole thing again, you will get some answer for the curve C2, and for this whole curve, which is combination of C1 and C2, you just add these two answers coming from C1 and C2. Okay, so the key thing is parameterization. If you have right parameterization, the whole problem is just followed by these, I think, 5 steps. Okay, next question. Yeah. 29. Find a flow line of this vector field that passes through 1 comma 0. You do not need to solve completely, it is enough to write the differential equation satisfied by x of t and y of t. So for this one, we saw that if r of t is the position vector, then the derivative of this one gives us velocity, and this velocity is same as the field that is given to us, f of x of t, y of t. And now if r of t has components x and y, r prime of t has components x prime of t I hat, y prime of t j hat, and the force field is negative y I hat plus x j hat. So this is simply coming from the definition, the left hand side. The right hand side is the force field or the vector field or the flow field that is given to us. If you just compare the corresponding terms, you get x prime of t, or x prime is equal to negative y, and y prime is equal to x. This is the system of differential equations. And then you can write like it passes through 1 comma 0. So you can write that okay y, or you can write at x is equal to 1, y is equal to 0. So this is just the differential equation and you do not need to solve this one. This is what mentioned in the problem. Like you can solve, we have some very simple examples that we could solve these, but in this one you can see x prime depends on y and y prime depends on x. So we can't do anything. Okay, so you can see there are some problems in lecture notes that we can solve, but like we can solve this one, but not with the tools that we have learned in Calc 3. You do a course on differential equations, you can easily solve this one. Next, yeah, 26. I think we can do this one. So if we do the same thing, this will give us x prime is equal to x and y prime is equal to 2y. We can solve this one easily. X prime is equal to x means that x prime means dx by dt, the derivative of x with respect to t, is equal to x. To solve this one, I am going to rewrite this thing by multiplying dt on both sides and dividing by x. So dx by x is equal to dt. If I integrate both sides, the left hand side is natural log of x, the right hand side is t plus c. Then this condition means that at t is not mentioned, so you can put t to be anything. For example, at t is equal to 0, x is equal to 1 and y is also equal to 1. So at some specific value of t, x and y is given to me, which is 1 and 1. So if you apply these values here, for example, x is equal to 1 and t is equal to 0. Natural log of 1 is 0. So the value of c becomes 0. If you substitute back it here, natural log of x is equal to t, and hence x is equal to e to the t if you apply exponential on both sides. This is coming from the solution of the first one. X is equal to e to the t. Similarly, if you solve y prime is equal to 2y and you apply the same condition, you will get y is equal to e to the 2t. That's it. So this is like the solution for x and y. If you want to get rid of t, we have done similar problems. You can get rid of t by rewriting this thing in this way: e to the t squared, and I know that e to the t is equal to x. So this simply becomes y is equal to x squared. It means corresponding to this force field or vector field, this is the flow line which passes through 1 comma 1, and you can see if you put x is equal to 1, y becomes 1. But this is like a typical ODE problem again. I will not be asking something like that. I can ask maybe this one because it is very easy to solve. You can see this one is x prime is equal to 1 and y prime is equal to 3. The solution is x is equal to t plus some constant, y is equal to 3t plus some constant, because you integrate both sides, that's it. And you find the value of c1 and c2 by using this point. That's it. So like these are some ODE questions. Just maybe you can ignore 26, 27 as well, not 27, but you can think of okay, there will be no such problem, and 29 too. Okay, yeah, you were saying something. find the potential function for, yeah, this is a question related to potential function. We have a way to do this thing. So, and this is again like there can be many questions asking you the same idea, find the potential function. So maybe you should practice on these problems a lot. So we are given this force field and we are given these 2 points. We are not explicitly said that okay, between these 2 points there is a line segment or there is a semicircle or something else, but it says that okay, since you can assume the vector field is path independent, so you should use this potential function to compute this line integral. And the idea of potential function, if you remember, is find a function f. In most of the books this potential function is given by phi, but we can say find a function small f such that if you take the gradient of this small f, you will get this big F. And since we are talking about only two space, so the gradient of the function is fx I hat fy j hat is equal to the field that is given to me, which is 3x square plus y I hat plus x plus 2y j hat. Maybe we can find this potential function or maybe not. Okay, so let's see, we can try this thing. So let us compare these corresponding functions. So fx is equal to 3x square plus y and fy is equal to x plus 2y. What should I do? So if we integrate this one, this is going to be x cubed, because you add 1 and you divide, plus xy plus a function of y. Now you differentiate with respect to y, this thing. If you differentiate, you get fy, the derivative of x cubed with respect to y is 0, the partial derivative. The partial derivative of x times y with respect to y is y or x, x, plus the derivative of c of y is c prime of y. Now you compare these two things. One comes from the problem and the other one that you just computed. If you compare these two, it means x plus c prime of y is equal to x plus 2y. You can get rid of x. Again, you can integrate with respect to y. You will get c of y is equal to y square plus some constant, let me call it a, because I don't want to use c again. You put the value of c back in this, maybe you can call this a star. If you put it back here, f is equal to x cubed plus xy plus y square plus a. So this is the potential function. A can be any constant, it can be 0 as well. If you take the gradient of this one, the gradient of this function, you will exactly get this big F. You can check this thing. Okay, now why this problem becomes easy? Because using fundamental theorem of line integrals, fundamental theorem of calculus for line integrals, this line integral is nothing but you evaluate this potential function, but let me rewrite this in this way first, because this f is equal to gradient of little f. Then if I have this thing, then here comes fundamental theorem of calculus for line integrals, which says that you evaluate f at q minus evaluate f at p. And what are p and q? P and q are these points. This one is p and this one is q. That's it. So f of 2 comma 3 minus f of 0 comma 1. That's it. You evaluate these two, take the difference, and you're done. Since the vector field is a gradient vector field, we can do this thing. From one point to another, you take any path, the line integral is always same. What is f of 2 comma 3? So it's 2 cubed plus 2 times v plus 3 square plus a minus 0 comma 1. 0 cubed plus 0 times 1 plus 1 square plus a. So this is 8 plus 6 plus 9 plus a minus this is 0 0. We can get rid of a, and this one is 22. Any questions on this one? This is a very good question. You may expect a similar question. Okay, so the method is same. Next.
Can you do
30.
Yeah.
Determine whether this vector field is conservative. If it is, find a potential function. How do you verify whether a vector field is conservative or not? We find a potential function. If there exists such a function, it means it is conservative, otherwise not. We'll do in next section, but I think we know how to do this problem. That's why I kept this here. So the idea is again same. Find a little f such that the gradient of little f is equal to big F. So fx will be 2x plus y, fy will be x plus 4y. Okay, I'm maybe skipping a few steps. So if I integrate this one, I'll get f is equal to x square plus x bar. And if I differentiate, I get fy. If I differentiate this one, fy is equal to x. No, sorry. Plus some c of y plus c prime of y. Okay, and now if you compare these two, x plus c prime of y is equal to x plus 4y. You get rid of x and you integrate, c of y is equal to 2y square plus a constant. So the potential function is x square plus xy plus 2y square plus a. So this is the potential function. Therefore, vector field what is the situation where this function does not exist? For example, this x plus 4y is not x plus 4y, this x plus 4y is x plus 4y plus sine x. For example, It means I have sin x here, so I am getting rid of x, then c prime of y is equal to 4y plus sin x, which is not possible. C prime of y should be a function of y, but in this case you can see c prime of y is equal to 4y plus a function of x, which is not possible, because we are saying that c of y is a function of y only. If you differentiate a function of y, you get only a function of y, or you get a constant. Sin of x is not a constant, it's a function of x. Hence, you can say that there exists no function f such that the gradient of that little f is equal to big F. Hence, the vector field is not conservative. Okay, so this is, maybe these are some sort of examples. Yeah. 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 So on left hand side, if you see c prime of y, right hand side should only be a function of y. It can be any crazy function of y that you may be difficult to integrate, but it will only be a function of y. And you can cancel these x. If you cannot cancel these x like that, then it means, yeah. Yeah. 11. No one is going for the questions at the end. It's okay. So for these questions, I think if you cannot integrate, like, I think it's not the right thing. If the integration is not possible, then you can leave it there. Okay. But you have to write everything that the length of curve is, you integrate from a to b, you compute the speed and you integrate it. Okay, it means the magnitude of r of t, or is it r prime of t? R prime of t. So r of t is given to you. First of all, you compute r prime of t, it means you differentiate both. So this is 2t and 2. So there is no I and j because this is written in this different notation, but everything is same. This is written in this notation. If you find something in this notation, it's okay if there is no I and j. Then what is the magnitude of this guy? It is root square of the first one, square of the second one. So I'm going to keep these things here, root 4t square plus 4, and you integrate from 0 to 1 dt. Okay, you can get rid of 4, it becomes 2 when it comes out. Can we integrate this? What's the integral? Trig? Yeah. Any other way? Substitution, use substitution. Like, this integration is not easy, but this is possible. So the simplest way is you do trig substitution. And if you remember some of the rules, if you do this thing, t is equal to tan theta, then you can do this thing. It means dt is equal to secant square theta d theta. So the whole length becomes 2 integral tan square theta plus 1 dt is secant square theta d theta. And then you can change the limits as well. If t is equal to 0, then theta will be 0. You can see that thing. If t is equal to 1, then theta is equal to pi by 4. But again, this one would be too much, I think, because tan square plus 1 would be secant square, and secant square and square root would be secant. So in total this would be secant cubed theta, and how to integrate secant cubed? Any idea? You can also do this one by using integration by parts, same problem. I think it's possible, but you can leave it, maybe you can leave this problem here, but obviously before that you need to compute these things, you need to write the correct formula, that's it. Yeah. So like on the exam tomorrow, if you were to ask a question like that with a bunch of, you know, if you do a bunch of different methods, is you want us to leave it like that, or do you want us to try to do? Yeah, so I don't remember the exam exactly, but I'll let you know tomorrow by looking at the exam that you have to do this one or not. Okay? Yeah. Yeah. Can you just say what you would expect for five on the five? What is the geometric meaning? It's the work done by the ocean current on the ship. That's it. Yeah. 32. Okay, so if we use like polar coordinates for this one, the question is really simple. So first of all, we have to look at this region. This is x square plus y square, which is equal to r square is between 1 and 9. It means r is greater than 1 but less than or equal to 3, r itself. So if you want to draw this region, this is basically what we call an annulus or a ring type shape that looks like this one. So if you put some x axis and y axis, this is exactly r is equal to 1 and this one is r is equal to 3, and this is the region that we are interested in. Okay, and if you want to write any integral, you know that this area element in polar coordinates is r dr d theta. And now you need to write what should be the limits. So if you start from any point, you are completing a circle. So the limits for theta should be from 0 to 2 pi because it's a complete circle. So this outer one corresponding to theta is from 0 to 2 pi, and the value of r is clear to us. It is from 1 to 3. Okay, it starts from 1 and it ends at 3. We are not including this interior region, it's only this annulus. So here comes the limits and here the area element. Here I need to write what function I am integrating. So this is the function, but I need to change this function into polar coordinates. So this is square root of x square plus y square is simply r. This is the definition of r. So I totally transformed this integral into polar coordinates. Now I'm going to evaluate this one. And evaluation is not a big deal. The whole idea is how you convert this. So dA is equal to dx dy if you are talking about Cartesian in 2 space, If you are talking about polar in 2 space, it is r dr d theta. These are the area elements, and you can see we can get rid of r, and now you can integrate. If you integrate the inner integral, so you are integrating 1 with respect to r, so this becomes r, the limit is from 1 to 3 d theta. So integration is not difficult. If you apply upper limit minus lower limit, you get 2 d theta. 3 minus 1 is 2. You integrate again, you get 2 theta from 0 to 2 pi. You apply a limit, you get 4 pi. So these questions are really simple. It's all like how you convert these, uh, like change these coordinates. Say it again. 33. So cylindrical, yeah, cylindrical is similar to polar, just we are working in 3 space. So the function is z. I'm not going to change z into anything because in cylindrical coordinates z is equal to z. There's no difference. And the volume element in cylindrical coordinates is r dr d theta dz. And now I need to just write the limits. So you can see z is between 0 and 4. It's a cylinder where z starts from 0 and z ends at 4. So this z which lies outside should have limits 0 to 4. And this is a cylinder, it means you are completing this circle. So theta should go from 0 to 2 pi. And from here, what do you say about what should be the value of r? By looking at x square plus y square is less than or equal to 1. 0 to 1. Okay. So this, if you want to draw this one, this is x axis, y axis. There is a disk in xy plane with radius 1. There is a difference between a circle and a disk. A circle is only boundary, the disk is everything on the boundary and inside. So this whole thing. And there's another disk here where the value of z is equal to 4 and here z is equal to 0. And you connect these, you get a cylinder. Okay, that's why theta is between from 0 to 2 pi, z is from 0 to 4, and r is from 0 to 1. Okay, now you integrate this one, that's it. If you integrate with respect to r only this, you integrate r, this becomes r squared divided by 2 because z is a constant. Then you integrate with respect to theta, everything is a constant. Then you integrate with respect to z, this becomes z squared divided by 2. So the integral is not difficult. But this is how you set up the integral. Okay. Yeah. 34. Yeah, I was waiting for someone to say something about this one. Yeah. Okay, so this one is spherical coordinates. The good thing is the integrands that you can see are really simple, but if the integrand is difficult, then the problem becomes difficult. So the volume element in 3 space, if you talk about Cartesian, the volume element is equal to dx dy dz, this volume element. If you talk about cylindrical, then the volume element is r dr d theta dz. If you talk about spherical coordinates, then the volume element is rho square sine phi d rho d phi d theta. Okay, so there's an extra thing that you can see. Now, what is the region? This is upper hemisphere of radius 3. So, if you try to draw this thing in 3 space, there is a circle in 2 space, but then you make a hemisphere like this. Okay, so this is like upper part of it. Shouldn't say this thing maybe, but you can understand this lies in xy axis, and then this goes in z axis, x, y, and z. So, what should be the limits? And the function that we are integrating is 1. The volume element is rho square sine phi d rho d phi d theta. The question is, what should be the limits? Once you decide the limits, you are done. What do you think? What should be this rho for the inner integral according to the problem? Its hemisphere are radius 3. So, it should be from 0 to 3 because the radius is 3. So, 0 to 3. And how about theta, which lies outside? Zero to pi. It's a complete circle. 2 pi. Then the last one is the angle phi. What do you think? It when it is 0 to pi, this is going to be whole sphere, not the hemisphere. And why do you think so? This is a bit like technical to understand why it is pi by 2.
The angle between the z-axis and
Yeah.
the radius.
Yeah. So what happens? You maybe if this is the angle theta between z-axis and this line, the red one, then it covers this whole space, z-axis, and you have an angle theta and you just rotate it, there is an space covered which is similar to a cone. Now you start from 0 and you increase the angle. Eventually when you become horizontal, this is 0 to pi by 2. So this covers the upper hemisphere. If you go beyond pi by 2, then you are also covering the lower hemisphere. So it covers the whole hemisphere, whole sphere. That's why phi is always between 0 and pi, and theta is between 0 and 2 pi. This is when, for this particular example, phi is between 0 to pi by 2. Now you integrate this one. Okay, I think integration is not difficult, because if you integrate with respect to rho first, then sine square is a sine of phi is a constant, you get rho cube divided by 3 sine phi, and the limits are from 0 to 3 d phi d theta. And once you apply the limit is for rho. So 3 cubed is 27, divided by 3, this becomes 9 sine phi, and for 0 there is no contribution. Now you integrate with respect to phi. The integral of, sorry, I'm messing around a lot of things. This is pi by 2. So the integral of sine of phi is negative cosine of phi. You can get rid of 9 just writing it outside, this is a constant. Negative cosine of phi from 0 to pi by 2 d theta. If you apply limits, cosine of pi by 2 is 0, so this is negative 0 minus 1, because cosine of 0 is 1 d theta, and everything here becomes 1. That's why you have 9 0 to 2 pi d theta. The integral of this guy is theta from 0 to 2 pi, so it's going to be 18 pi. What is the volume of a sphere with radius 3? 4/3 pi r cube. Is it the formula? What is radius? 3 cubed. 36 pi. So our answer is 18 pi, which is correct because it's hemisphere. And we are integrating 1 on that whole volume region. That's why it should give us volume, because the integrand is 1 itself. Okay, any questions? I got 3 more minutes. If you have any questions, let me know.
Can you just briefly talk about the first 5 questions because they're kind of conceptual?
Yeah, you might expect some multiple choice questions based on these. So it says that the first one, the vector field is perpendicular to the tangent vector of curve C. It means whatever the curve C is, this is its tangent vector everywhere. So the vector field is perpendicular to this. It means the vector field is perpendicular to the curve. And you know that for computing line integrals, we have this dot product. So this thing should be 0, because the curve and the vector field are perpendicular to one another. And you know that if you reverse this direction of negative c, they are equal but with the negative sign. These two quantities are equal but with the negative sign. You can put negative sign here or here, you know there's no difference. Okay, just rewriting the same thing. And you know the formula of this thing, you integrate from a to b f of r of t and dotted with r prime of t dt. This is the formula that we use. And I think this talks about parallel. If they are parallel, this thing is always greater than 0. Parallel and point in the same direction. If they point in the opposite direction, this is negative. Okay, so parallel doesn't mean always positive. In geometric meaning, you know it's work done. And for this one, you know that this guy is equal to the sum of these two, because C is a curve that is combination of C1 and C2. I shouldn't say combination because the right word is concatenation, but it's okay. And there's one more question, which is this one. So if I'm given these 4 values, how can I compute A? You know that I can rewrite this thing in this way: f dot dr minus g dot dr. It means if I have 2 vector fields f and g, and there's a third vector field which is difference of f and g, then how do I compute this like integral of f minus g on the curve C1? So I just compute by taking this difference. And do I know this value? Yes, I know. Do I know this value? Yes, I do. So just substitute. Similarly, you know that this is C1 plus C2, so you just write C1 f dot dr plus C2 f dot dr. Okay, and I know the line integral of f on C1 and line integral of f on C2. I know these two. And the last one is not that tricky, but you know that if I get rid of this negative sign, I write negative sign here. And since 2 is a constant, I can also get rid of that. G dr. Now the question is, do I know the line integral of g along C2? The answer is yes. You multiply that thing with minus 2 and you're done. And you know that where this negative sign comes from, where this 2 comes from. So I'm just keeping this 2 outside and I'm just writing this negative sign here. That's it. And you know these are equal. So you may expect some questions like these as well, some simple questions. Okay, so wish you best of luck for tomorrow.